Hey there, and welcome to stream number 2. My name is Mehdi. I'm a software engineer by day and I guess a streamer by night. If you didn't catch my first stream yesterday, you are not alone. About 7 billion other people also didn't catch it, but yesterday was my first stream, and I basically wanted to explore streaming as something that I want to do, and I had a ton of fun and doing it again today. So, ready to launch into it. So, today we're going to be solving a programming challenge from the Advent of Code. This is what we did yesterday as well. If you don't know what Advent of Code is, it is an Advent calendar of small programming puzzles, as you can see here, that are basically incrementally harder every day. Every day you get a two-part challenge that you have to solve, and you get a shiny gold star at the end of it. Um, so yesterday we solved the first day's challenge using the Rust programming language. So if you watched, you might have realized that I'm new to Rust and I'm also new to streaming. So it was super challenging learning Rust and solving a new programming challenge and learning how to use my streaming setup all at the same time. But I had a ton of fun, and I think today is going to be a bit better, and I'm very excited to get going. So I'm going to go ahead and look at before we look at number 2, I want to take a look at some of the code that we wrote on the stream yesterday. I went ahead and did some reading and learning after the stream to better understand some of the code that we wrote and some of the mistakes that I was making. And I think I have a better understanding of Rust today than I did yesterday. And I have to say, it's a really interesting programming language. I come from a background of working with dynamic, very kind of um, Wild West programming languages, super high level languages like JavaScript and Python. So I don't do a lot of work with systems programming languages or even statically typed languages very often, but I've worked with them in the past. In particular, though, a low level language like Rust is very new to me. However, Rust is a very interesting programming language because although it's a low level kind of systems language, it does have um, a lot of syntax and kind of concepts that you would often see in higher level programming languages and more dynamic programming languages that you're used to using, such as Python or JavaScript. Um, and um, and I think that makes it a very compelling systems language to learn if you're someone of my background. Rust has really excellent support for WebAssembly, which is one of the reasons why I want to get comfortable with Rust. But also, reading some of this code, especially reading idiomatic Rust code, is not uncomfortable for someone like me who spends all of their time kind of reading JavaScript and building user interfaces. So I think that's what makes Rust very interesting. Anyway, I digress. Let's look at this code that we have. So if you did watch the stream or the broadcast yesterday, you'll notice that this looks very different. I solved the second part of the challenge after getting off the stream yesterday, and it was kind of a very, I'm shocked that I didn't see it on the stream, but it was a syntax error or rather a logical error with the way that my nested loops were set up. So I kind of went back and just rewrote everything in slightly more idiomatic format, um, and we'll go over that. And also, you might notice I have these awesome type hints now. I installed an extension called Rust Analyzer. Here it is, which is kind of an alternative to the um, official Rust for Visual Studio Code extension. And I find that it's got these really nice kind of type hints that tell you what you're looking at as you're writing the code. In this case, because Rust is statically typed, it's very important to know the type of whatever you're working with, but at the same time, um, because Rust is got these like kind of niceties, I guess. There's a lot of type inference going on, so it's very easy not to know the type of something you're working with, especially if you're new to Rust. Anyway, um, so this kind of revised code is by no means idiomatic, but I'll just go over it really quick. I don't want to spend too much time or even try to refactor this because I want to kind of move on to more interesting things like day 2. But you might notice one thing I did was split our part 1 and part 2 into 2 separate functions that return an option type. option types are very interesting in Rust as they're kind of this. I suppose Rust doesn't really have exception handling the way that you would expect from languages that you've worked with in the past that throw exceptions. In fact, Rust doesn't really have, at least so far that I know of, doesn't really have like traditional exceptions that are thrown. Rather, the way that errors are handled and the way that like null values are handled or none values are handled in Rust is using these option or result types and using enums. So that's very interesting because it kind of encourages you to handle potential errors, I suppose, more aggressively or more proactively than a language that doesn't, I guess. And it probably makes for more resilient code and makes for easier debugging if you know where to expect a potential error. So you might notice both of these functions are returning an option type. It's an option I32. We don't need to use a signed integer here, but we just do just because it's easy. We don't really care about memory or performance for these challenges right now. Excuse me. And so by returning an option I32 here, what we're saying is that the return value of this function is either going to be a 32-bit signed integer, or it's going to be a none type. And a none type being just no value, similar to something you would expect to be like null. However, you're not going to like just pass a none value or like return a none value. You're going to return an option type that then the callee of this function is going to have to explicitly handle, which is super interesting. Another thing that we did was another thing that I did was to better understand what was going on here. So this isn't wholly unfamiliar to me. This is like very much something like what you would see in the more functional side of JavaScript code, and which is basically like list manipulation. So reading our input data, we're reading it to a string from a file and unwrapping. This unwrap method, all it does is basically say, I don't care about your option type, just give me the resolve value. I know it's not going to fail. Splitting by white space basically just it's very self-explanatory. It splits it into a collection. And then we apply a bunch of transformations. So like in this case, we have a map, a filter, and a map. If you're not familiar with what those are, basically a map is like a one-to-one transformation of an input value to an output value. So you're going to have a list of the same size, but with like a transformation applied to every element, or I guess conditionally applied. A filter is somewhat self-explanatory, but you're going to input, you're going to have like, you can iterate over your collection and have a collection of equal or lesser length, and you might be using some condition to filter out values. Like in this case, we're filtering out any values that are empty, and then we're doing another transform, which is to parse the strings as integers, and then we collect. So what collect does is basically turn the iterator that we have here into like a collection type, in this case a vector. And what that allows us to do is just to apply a bunch of transformations to the transformation pipeline and then just collect them all in one go, so that we're not like we basically just do it all in one shot, and then collect the result as so these are iterators, and this would be a vector type. That's what this would return. We also sorted our data and returned it. And then part 1 and part 2 are really what are called like the 2-sum and 3-sum problem. This is not by any means like the most optimal solution, but it's the easiest one, and it's one that doesn't really, I guess, come into like where performance doesn't really come into play for a challenge like this. Like the input data wasn't super large. We weren't working against like a ton of constraints. So it just did some nested loops here, and basically, if you remember the challenge, it was to find combinations of values that sum up to 2020 and then return their product. So we're returning an option type here. And Silence, I know you mentioned you can catch panics, but that's about it. That's a really good point. Panics are kind of the closest thing you would find to a traditional exception in Rust, and they're from what I understand, at least, they're meant to be like something is seriously wrong, like your software is breaking. So um, it's kind of like typically with cases where you would expect the value not to exist, you wouldn't be relying on panics, but rather like option or result types. But correct me if I'm wrong. Thanks for the help. Um, anyway, so one last thing is that these you might notice that these like enum types kind of look like functions also, and that's because enums in Rust are really cool. You can kind of give an enum a type. So an enum is kind of like a generic, or it accepts like a generic type, which is kind of cool. It allows it allows for something like this where you have option I32. And also, like, we'll probably, I imagine, as we kind of move forward, as we're using more language features, get into like enums and pattern matching and why they're useful in Rust and all that kind of stuff. And I'm still like kind of trying to fully grasp all of that, but I'm going to try to use more language features, and I probably would need to for some of these challenges, specifically to help me actually learn the language rather than just get the answer. Anyway, so that's enough about day one. I'm going to take a sip of tea, and we are going to move on to day two. And so first thing I'm going to do here is make a new directory. Actually, I'm going to create a new cargo project. Cargo is the kind of build tool and package manager CLI for Rust, and it's super awesome. So I'm going to say cargo new day two. And now we see we have a new directory, this day two directory. I'm going to close this stuff. Make sure, make sure our terminal instance right here, our shell is in the day two folder as well, and open up my source file. So we're greeted with kind of like the same hello world starter, and if we do cargo run, we're going to get hello world printed, which is great. You might notice my Windows subsystem for Linux warning is gone. I spent like a couple hours upgrading to Windows subsystem for Linux 2 yesterday, which was worth it. Anyway, so let's go ahead and look at challenge number 2 and see what we have in store. All right, so your flight departs in a few days from the coastal airport. The easiest way down to the coast from here is via Toboggan. Is that Toboggan? Toboggan. I'm not 100% sure how to pronounce that, but anyway, let's keep going. So the shopkeeper is having a bad day. Something is wrong with our computers. We can't log in. You ask if you can take a look because you're a hacker, I guess. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed. Try to debug the problem. They have created a list, which is your puzzle input. So similar to yesterday, we have like input data that we're working against, of passwords according to the corrupted database, and the corporate policy when that password was set. So let's look at this list. This is an example list, and probably the way I did this last year was a lot of, for some of the later challenges, they get more complicated, and I tried to do like a more like test-driven approach to solving some of these because you don't really know, it's harder to iterate. So I would sometimes start with just writing tests against the example and then kind of go from there. We'll get there eventually, I'm sure, but for now, I don't know if we need it. Anyway, each line gives a password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. For example, 1-3A means that the password must contain A at least one time and at most 3 times. Okay. In the above example, 2 passwords are valid. The middle password is not. It contains no instances of B, but needs at least 1, and I suppose maximum of 3. The first and third passwords are valid. They contain 1A or 9C, both within the limits of their respective policies. How many passwords are valid according to their policies? Whew. All right, deep breath. So let's first go ahead and grab our input data. So we can see we have a ginormous list of passwords here. And I'm going to, once again, create a file called data.txt in the root of my day 2 cargo project. And I'm just going to paste everything in there. So these are all the passwords that we're checking. And let's look at what we're trying to get again. So we're trying to get the number of passwords that are valid according to their policy. So we're going to have to do some text parsing here. Each password has a policy. Well, I guess a minimum, like a min-max of a letter or a character, and followed by a string, which is going to have some number of characters, but most importantly, should have a rate of occurrence, or I guess the number of occurrences of a character for that specific character that falls into this range right here. So that was probably the worst possible way I could explain this, but it seems like not too difficult of a problem. So let's see if we can get started. Now I want to do the same thing that I did yesterday after the stream, which is to just create a separate function for part 1 and part 2 for now. So I'm going to create a function part 1, and I want this to return just a 32-bit integer for now. Let's see what we're working up against. What we're trying to get is how many passwords are valid based on their policy. Now, let's go back and look at the data again and kind of talk about what we're trying to actually do here. So the first thing is that this file is basically a list of, you can treat this as a list of inputs that we can iterate that are separated by new lines. So the way I did this yesterday was this kind of like super long way to do it. I think I attempted to use the lines method on string, which I'm going to use today because I think I understand it a little bit better. But Rust gives you a handy lines method on your strings that will handle splitting your string by carriage returns and new lines and all that kind of stuff. So we don't really need to do all of this. I suppose in this case, we only needed to parse these as integers, and we might need to do that for specifically for the range part of what we're doing. I also could use regular expressions, but I believe that there is no regular, well, so the standard library in Rust doesn't include regular expressions module. That's not to say that it's bad to use. It is just the way that Rust develops, and that a lot of what you might expect in different languages to be a part of the language or part of the standard library is split out into crates, which are basically packages that can be then updated more frequently. So I'm gonna at first at least stay away from using the regular expressions module, just because I want to, I think that's kind of a meta language that I'm already more comfortable with than I am with Rust. So I'm going to try to use this with just no external or no additional crates. Looking at the data, essentially we have 3 parts to each of these passwords and their policies. One, which is the range itself. So maybe this would be like a tuple of a minimum and a maximum, because these are all going to be pairs. We have a character, which is going to be the character that we're looking for to fall in that range. Maybe like this is what we want to parse it out as. And then we have like the password string itself. So so I suppose let's try to get our input data in a data structure that we feel comfortable with. So let's say get input data. And what is this going to return? I don't know yet, but I have a feeling that it would be just handy for us to use this as an opportunity to use like to define like a struct or like a custom data type for this type of thing, just because, just to learn it. But first, let's actually pull in the file. I'm going to use the the file system module here from the standard library. And as you remember from yesterday, file system has a read to string method that you can use. So this is a static method that returns a string, or rather a result string. So I'm going to say let raw data equals file system read to string. And I'm just going to unwrap that. And I'm noticing for whatever reason, I'm not getting like IntelliSense here. So let me see what's going on. There we go. It just kicked in. And it's telling me that I'm not returning an integer. So wonderful. Now, we have our string, and you know, it's useful as a string, but it's probably more useful as a as an iterator, so that we can iterate over it and transform it to what we want. So I'm just going to say let passwords equals raw data lines, and this is going to give me an iterator, and then I'm going to maybe look at what we're trying to actually do here. Well, let me just kind of close this. So in this example, what we were doing is splitting by white space. Lines is doing something similar. It's returning an iterator, but then we were kind of mapping over that and trimming each one and filtering and mapping. So what we could do is the same thing, but I'm wondering if we could just iterate over this and then just kind of stuff our or you know, like map this to not just a like strings, but actually create like a data type, like a password data type that we can use. So I'm going to try to define a struct for passwords, and I'm just going to say struct password. And like we said, we have like three components. I don't need my code from yesterday. Our three components are the range, the special character, and the input itself. So I'm going to say range. Let me just double check the syntax for structs here. So Rust book. So as I did yesterday, I'm going to rely quite a bit on this book called The Rust Programming Language by Steve Klabnik and Carol Nichols. It's kind of the Rust, it actually comes with the language. It's a book that is very well written and covers lots of different aspects of Rust. So it is definitely like as close to the guide to Rust, like the official guide to Rust, as you're going to get. And let's look at structs. And let me, is there a search here? Okay. Using structs. Okay, this is probably going to help us. So this is the syntax that we're looking at for structs. If you're coming from an object-oriented language like Java or C#, you might be thinking of structs as classes. And what I learned last night is that structs are well, the way that Rust handles types is very different compared to, for example, Java or C#. And that structs kind of define the data structure of a type, and you have what are called like impl blocks, or like implementations that define like the behavior or methods on that type. So in this case, like you don't really have methods on your, you can't have methods on your struct. You can kind of add an impl to the user type in this case that would define methods on the user. You also don't have like a special constructor function. That might be something you're familiar with. I don't know if we're actually going to use impl today, but let's just use this data type or this struct for now. So I'm going to define a struct. And then my range is going to be a tuple of I32, I32. My special char is going to be a string, and my input is going to be a string. Actually, I think my special char is going to be a char. Okay. And so this is just going to be a single character. So basically, what I want to do is map over my iterator, and for each of the inputs that I have, I want to create a struct, a password struct that actually has a range, a special character, and an input. I'm going to try to actually use a special, another feature of the Rust language, which is the closure. I'm familiar with closures from my day job, and I use closures and I understand them in the context of the languages that I use them in. But I'm going to try to see if I can use a closure in this case, and not because I have to, or I don't think we need to in this case. Like, we could just iterate using a for loop, but it's just kind of an interesting thing. So closures, if you're not familiar with them, you might know them as, like, if you're a JavaScript developer, you might know them as like arrow functions. They're very similar. Essentially, a closure is an anonymous function that kind of captures values or references from its outside scope, and closes over them, meaning like that they're available in the scope of that function. And that's, in a language like JavaScript, that's very important because like modules rely on closures for things like private variables and private values. And then if you're like working with React or something like that, you're relying on closures all over the place to kind of capture values at a specific point in time or snapshot in time. That's why when you're writing code that is based on a particular render of a component in your user interface, for example, that's why those values are correct, and like that they're the values at the point where which that component was rendered. Anyway, so let's look at closure syntax in Rust and see if we can emulate it. And actually, in our code, we used closures yesterday, but not knowingly. So hopefully today we'll be a little bit more intentional with it. I'm just kind of scrolling through to see if I get a syntax example. I think maybe this is doing, this is kind of explaining what we're looking at. Let's see, next is the main function. Okay, so maybe this is closer to what we're trying to do. Processing a series of items with iterator. So we have an iterator that we're creating using an iterator and a for loop, so we can do that, absolutely. Okay, this is what I was looking for. So Rust has a syntax for using kind of inline anonymous closures with like an implicit return that looks like this. From what I understand, the value in between your pipes is kind of like the thing being captured in the, like the thing being closed over. In this case, map is probably passing in the value of your like the next value that is yielded from your iterator into your closure. In this case, it's going to just be like an i32, and then this is like returning, this function is returning that value plus 1, and we're just collecting that into a vector. So what I'm going to do is try to emulate that. I'm going to call hold on. So let's see, what am I actually missing here? A semicolon, as it turns out. Takes a closure, so we have some docs here as well. Takes a closure and creates an iterator which calls that closure on each element. Map transforms one iterator into another by means of an argument. So let's give this raw, which is going to be an ampersand string. That's like a reference or like a borrowed string. And that's another concept that we'll probably have to face at some point. And I'm going to open like a block. And I think I have to give my return type. So I'm going to give it a return type of password. So essentially, this this block should evaluate to a password type. So one of our structs here. And then just to make the errors go away, I wonder if I can. Oh, maybe I probably need a like kind of a constructor-like function. So pub new. Well, hold on. How do I just create like? How do I just instantiate? Let's look. Defining and instantiating structs. Okay, so this is the this would be the syntax for instantiating a struct. So let's see if we can just instantiate a dummy struct here to make our errors go away. So password range 2, 4 or 2, 3, I guess. Special char a input a, or I guess I need like double quotes for that. Expected string found string. There we go. And we need a semicolon. Great. So this actually makes everything go away. And I'm going to say, like, let's just print this. And call it. And run it. Because expected named lifetime parameter. Consider introducing. Oh, okay. Interesting. So the compiler is telling me that it expected a named lifetime parameter. I'm not sure what that is yet. And then it gives me some help. Consider introducing a named lifetime parameter, which looks like this. So I'm assuming what it wants me to do is basically give a name to the string, kind of like the borrowed string that we're using here. And full disclosure, I'll probably learn more about lifetimes as I understand like stack versus heap allocation and all that kind of wonderful stuff that I don't, my naive understanding of low-level programming doesn't allow me to get quite yet, but I'm just going to trust the compiler for now, just because it seems like it's a good idea. And voila. So now let's take this out. So our program compiles. Great. So we don't actually get anything printed from our get input data. Oh, because we're not actually invoking the part1 function. Well, great. Yeah, there we go. So this is good, I think. But it doesn't look like we're actually returning, like, it doesn't look like this is an iterator that is, I don't see any password types, let's just say that. So I wonder if I have to collect to actually do the transform, and then this is going to be maybe a vec password. Can I just add, what does it say to do? Add derived debug. Hey, there we go. We added a trait. So great. So we actually have a, you can see a bunch of passwords. They're all identical, which is not at all what we want, but it is the same length as our list of input data, which is what we want, which is wonderful. So now let's actually get to doing the thing that is actually going to make this work, which is to stuff this, I guess, like stuff the actual data into our password types, and then validate each one. Before I do that, I noticed like my iterator, like the iterations of, like, I had a bunch of new lines, so I think I need to actually do a map val trim to trim each one of my strings. And then inside of this block, now we're going to have to do the work of splitting this one into the things we actually need. So first, let's look at what we have here. This input data, one thing that's kind of annoying about it without using regular expressions is that it would be so easy to just split this by a white space if we didn't have this colon. So what I'm going to do is actually just replace colons in my raw value. So I'm going to say let process string. This is probably a poor name for it. I'm going to say raw replaces all matches of a pattern with another string. Replace old new. So I'm going to say replace. Let's give this a character of colon, and then kind of just give it an empty char or an empty string. That works. So now we have now we can what we can do is actually then split on white space. So now this is not let's call this components, right? So this split char is now going to be I believe an iterator. Let's make sure that, let's see if we can, yeah, it is. Okay, great. That is going to have its components split, like it's basically going to have three different components that are split by white space. So my first component is going to be the range. So I'm going to say let range, and just going to add a type annotation here for comfort. And I'm going to say components.next, which is going to yield the next value in the iterator, which is going to be the string value of, like, the string part of this. And I'm going to say split well, okay, so what is this actually going to give me? Let's not define it. Okay, option next unwrap. There we go. I know it's going to be there, so that's famous last words. And split by a hyphen. What's going on here? Temporary value dropped while borrowed. That's an interesting. Okay, first of all, this needs to be mutable. And then so let's let process let's split this into two bindings. And then let components process split. And then I'm just going to use a white space. And this needs to be mutable. Great. So now our range is going to be be an iterator of strings. Now I need to map over that, give it or parse the string is integers and collect. Now this is actually going to be type annotation needed. I wonder if this is going to give me, yeah, as I expected, like this is giving me a collection which is not necessarily like a tuple has a defined length. I can't just take a take my what's it called, my iterator and then just collect it into a tuple with like type inference or anything like that. That's not going to work. So I'm just gonna call this like range vec, I suppose. Okay, that works. Let me format my code a little bit so it's easier to read. And now so I suppose I could just do let range equals, well, let's just do it over in our struct initialization. Range is rangevec 0, rangevec 1. Special char is going to be whatever components 2 is. Oh, I'm sorry. I forgot I need to actually do this. Let me rename this to just range just to make the code easier. That range, and let's let special char equal components next, and call this special char, and then let input equal components next. That's going to yield the next value in our iterator, which is going to be input. Expected type char. I need to unwrap these. And then this is going to be of the wrong type. So I'm just going to change the type. That's the way to do it, right? And then, of course, sure. Process is borrowed here. So cannot return value referencing local variable processed. So maybe I should just copy these. Can I just copy or clone? There we go. Is this something that I can do? Change the field's type to have a statically, oh, well. Only the last field of a struct may have a, okay, so maybe I can give this char type, and then special char is going to be, let's see, rust string as char. special character is going to be chars. Okay, next. Unwrap. Hey, it's a char. Okay. And then this is, what is it telling me now? The size values for the type string cannot be known at compilation time within password. Mismatch type found string, or expected string found a reference to a string. That's okay. What now? Okay, so I got the same reference error. Not cloned, but to owned or to string or into. Okay. To owned or to string or into. So, or I guess to owned. Let's try that. And then we don't need, what does it tell me? So now I can just do this. Is that right? Oh no. To string. Expected. Okay. Yay. Okay, this works. Awesome. Thank you. Great. So so look at that. We actually have what looks like actual workable data. Now we should just return this. Can I do, I guess I should just do this, right? And now, sweet. So it looks like now what's happened is that that we're able to get all of our input data looking like the way we wanted to, which is great. Now we need to make sure that the passwords themselves are valid based on the policy. So let's actually make sure our ranges are, well, I suppose we can be sure that the ranges are in the type that we want them to because we've defined that type here. So let's see, how would I do something like, how many times does a character occur in a string? Like Rust, how many of character in a string? Substring occurrences in Rust. So, oh, okay. So I could do something like string.matches.count. So like call the matches method. Let's look at string matches Rust. So this is the string docs. Let's search for matches, and matches, an iterator over the disjoint matches of a pattern within the given string slice. The pattern can be a string, a character, a slice of characters, or a function or closure that determines if a character matches. So let's go ahead and maybe add like an isValid method to our password. Now, how do I get, so I guess self is my, how would I get the self in this situation. Let's look that up. So Rust impl self methods. Okay, so in order to get access to like the instance inside of a method in your implementation block, you can define this like reference to self parameter in your function. So we're going to do that. Okay, and now I can say self input or self.range, self.special character. And then we can do something, I think, like self input matches self special char. Well, let's capture this. Let occurrences, or let count is self input matches self special char count. And then we're going to return count greater than equal to range self range at index 0 and count less than or equal to self range 1. Is this going to work? Oh. Cannot index into, okay, so maybe we could do let min max equal self range. And then min max, or here we go. Expected U size found I32. Okay, let's just Google this. How to idiomatically convert between U size and I32. Rust forces you, the as operator works for all number types. So can I do something like as I32? No. Okay. So let's look at count, and it's returning a U size primitive type. How many bytes it takes to reference any location in memory. So I wonder if we can get a non, like not a U size type, but a something we can compare to an integer, or if we can see the elements of the count size. Just cast it to I32. So what does the casting syntax look like in Rust? Oh, I32 from or v as. So I should be able to do something like like that. Oh, I'm sorry. No, I'm casting the wrong thing. Okay. Acquired by from. Oh, I have syntax errors. 32 from use size is not. So I do that. Oh. Can I do that? Yes. And then I can just do this. Thank you. Makes sense. Awesome. Sweet. Thanks so much. This is so this should be able to return like a true or false. So we should be able to get input data and then I guess iterate. I don't know why we collect. I guess so we could just iterate over this and then map or filter. Well, passwords get input data, and then maybe we could say return passwords. Create an iterator from it. Filter pass is valid. As I32. Does that work? Oh, unwrap. Or rather, select. Well, okay, let's give this. This is not going to be an I32, but it's going to be a vec tool. No. Alrighty. Actually, instead, what I'm going to do is just do this, and password in. Let me scroll up a little bit. In passwords, if password is valid, num valid plus equals 1, num valid. And return I32. So awesome. Now, what is this telling me? Temporary value dropped. Rather than doing this, I'm going to do this. Wonderful. And one answer equals part 1. And let's just print our answer. Great. So this should do it. Let's find out. Are we still... Okay, great. Part 1, 515. Great. So we got an answer. It looks like this at least did something. let's go figure out if that was a correct answer. So moment of truth, 515. That's the right answer. Awesome. Let's look at part 2. I might not have enough time to do it, but we also might. So let's just look and see what it is. While it appears that you validated the passwords correctly, they don't seem to be what the official system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job. Hate when that happens. Each policy actually describes 2 positions in the password, where 1 means the first character, 2 means the second character, and so on. Be careful. Oh, okay. So it's like a 1 base index. Got it. Exactly one of these positions must contain the given letter. Other occurrences of the letter are irrelevant. Okay, so let's figure out what is actually going on. Each policy actually describes 2 positions in the password, where 1 means the first character, 2 means the second character. So this is no longer a range, right? It's just 2 positions. 1 being the first position that we need to check, 3 being the second position that we need to check. And I think this one is valid because position 1 contains A, but position 3 does not. Or I'm sorry, this is... What is going on? Okay. It's valid. Exactly one of these positions. Okay, so one of them, so it's like an or, right? Like if this is giving me 1, 3A, either 1 or 3 should have the character A. If both of them have it, or if neither of them have it, then the password is invalid. So in this case, we have 1, 3A, 1, 3B, and the 1 and 3 positions are C and E. So this one is invalid. In this case, this one is invalid because both positions 2 and 9 have the character C, but only one of them need to have it. So yeah, let's try to do that really quick. This should be somewhat simple because I think we can just reuse a lot of our code. So what I'm going to do is first rename this method to part is valid part 1 to kind of delineate. I'm just going to write basically a second validator. Part 1. So then let's define a second function, and let's call it, or I guess another function, part 2. And let's copy the same code. I guess we don't really even need to duplicate all this code. It doesn't matter. I'm just going to copy paste because in the interest of time and the fact that this code is probably not going to change very much except for just a single method name, but is valid part 2. And then let's copy all this down. So part 2 answer 2. A lot of redundant stuff here, but that's okay. And so now all we need to do is write is valid part 2. And all it needs to do is just handle that kind of special validation logic that we had before, which is great. That's why we kind of define this data type and all this kind of stuff. So we don't have to worry about different text parsing or try to peel the code out of here. So let's do that. Function is valid part 2, and that's going to give us a Boolean. I'm going to say count is going to be the same. Well, actually, no, it's not, because we don't care about the count. What we need to do is let first position, second position, like basically unpack that from the range tuple. And then what we need to make sure is true is that either the first position or second position um, of the, like, whatever the value of this is plus one, and whatever the value of this is plus one, only one of them can be special character on the input. So if, well, I guess let's do something a little bit different. How do I how would I just like grab tuple at index? Is that possible? Oh, okay. So tuple dot index. Great. That'll make it easier. So I can, what I can do is just do let first position equal self range 0 plus 1. Let second position equal self range 1 plus 1. Thank you for that. This is awesome. This is like pair programming. And then now what we need to do is first make sure if both of these are the special character, we need to just fail. So if input at first position is special char and input at second position is special char, return false. Else return input first position or input, so like that equals special char, or input at second position equals self special char. And of course input needs to be self.input, and then type string cannot be indexed by I32. It's actually -1. Oh, you're right. Totally right. So that being because if we get 1 here, we want to look at index 0. That makes sense. I had it twisted. The trait index I32 is not implemented for string. I think Google is going to help me on this one. How to index a string. Indexing into a string is not available in Rust. So if you're certain that your string contains ASCII characters only, you can use the asBytes method on ampersand string, which returns a byte slice and then index into this slice. So I think this would actually work. This would actually work. So let's say like let first char equals self input. Let chars vecchar self index chars collection or collect. Let chars vecchar self index chars collect. I see. So yeah, that makes sense. So basically just using, yeah, perfect. Or input. That makes sense. So instead of worrying about indexing a string, we can just create like a vector type of characters that we can index easily. And this is going to tell me that I need to define a type for it. Actually, it's not, but let's see if like basically self input now becomes chars. And this says type must be known at this point. So I do need to define a type. And then the type char, can I be indexed? Interesting. Slice index char. Um, oh. I think I do need to, okay. Returns an iterator recharges with string slice. Um, let's look up this error. I'm wondering if I need to not use an I32. Need usize. Okay, so I should, can I cast to usize? I can. Awesome. So any parens here? Yep. Awesome. Okay. Well, this is really, really good to know just because I'm assuming I'm probably going to need to do this a lot. Probably for maybe I know there's like Advent of Code always has like a lot of, or at least last year there was a lot of text parsing. So probably for future videos I'm going to start looking at using the regular expressions crate, but I'm definitely going to need to be like indexing character collections and stuff like that. And this is a lot of the things I take for granted with higher level languages, that it's like I don't have to worry about like having a not having to worry about or not knowing the idiomatic way to do things like this is like something that's part of the reason why I'm trying to learn, right? Is because I want to understand it better. So it looks like we get an answer, but one thing that we need to change is actually change what we're printing, which is just to make everything nice and tidy. So it looks like we, by doing that, now we're getting 711 as the number of like part 2 passwords that are valid. Let's go ahead and test that. Awesome. Nice. So that was correct. And it looks like we are all set for part 2. So yeah, sweet. How do you pronounce toboggan? Um, I really want to know this now. I don't actually think my audio is coming through. Anyway, it's because my headphones are off. Toboggan. Okay, great. Wonderful. Thank you all for watching. A special shout out to Silence or Silenzy. Tell me if I'm pronouncing that incorrectly. For all of your help. I feel like I'm pair programming, which is awesome. And anyone else who watched, this was super fun. Maybe back tomorrow with day 3, depending on how my day goes. But I super enjoyed it. So thanks and see you next time. Oh, and I'm going to take a look at your solution too.